Today, let us begin with Docker Swarm. What is this Docker Swarm? Let's see. We are running multiple containers now, right? Like we were running a multiple number of PHP containers, DB containers, particularly for microservice applications. Each service may have to be scaled up or scaled down. Like yesterday we have seen we started 2 PHP containers. Maybe tomorrow, if you have so many user requests to handle them, we may further increase the number of PHP containers, meaning multiple containers. So when you have to manage multiple containers, also you may have to manage these multiple containers on a bunch or else on a group of Docker hosts. Right? What is a Docker host? This terminology, understanding the terminology is very important. What is a Docker host?
Like cluster.
Docker host.
Docker registry.
Docker host is nothing but a VM or a server, physical server, or a VM where Docker is installed and Docker is running, right? Where your Docker engine is running. So that's a Docker host, right? In our case, till now, EC2 instance is the Docker host. If you are running containers on your laptop, that particular laptop is a Docker host. So Docker host is nothing but a machine where your Docker is running. So there might be a group of Docker hosts. Till now we were working on single Docker host because I just need one container or 2 containers. But what if in a real application you need hundreds of containers for each service? So to accommodate them, you may need a bunch of Docker hosts, right? So see earlier, if I want, let's say 100 PHP containers, like we have some PHP front end, right? So we used to launch them directly on a virtual machine. So it would take 100 VMs. But now we already learned the concept of containerization advantage and all. Rather than running 100 VMs, we would run all these 100 containers on maybe a bunch of 5 VMs. See, number is always an example and the number depends on the resources available. Like 100 containers, if they consume less resources and the VMs are also, these VMs have enough resources, 5 would be enough. If let's say 100 containers or like they contain a lot of things and the VMs are very small, you may need 10 VMs. So it's always a number example, but definitely less number of VMs on which you can replicate them to the number, desired number, right? So this bunch of Docker hosts is nothing but like you want to manage containers on this bunch of Docker hosts. What is meant by managing containers on the bunch of Docker hosts? Please, everyone, keep muted unless you have a question. So we need to manage containers on the bunch of Docker hosts or Docker engines or bunch of Docker hosts or Docker engines or a pool of Docker hosts, whatever you call them, right? So you want to manage all these containers. What is meant by managing? See, manage, the term manage has got very broad meaning. Manage means like, let's suppose you want to run 5 containers, right? And let's say these 5 containers are distributed across 2 Docker hosts. Here, let's say Docker host, not VM, because VM is just normal server, right? But Docker host is a VM where Docker is running. We need Docker hosts. So let's say these 5 containers were shared across 2 Docker hosts. Okay, let's say this is Docker host 1, this is Docker host 2, host 1, host 2, here 3 containers, here 2 containers. Let's suppose this host got crashed or something happened, this host went down, crashed or deleted something. But you need 5 containers to accommodate all the user requests. There might be 100 end users, so to accommodate them, you need 5 containers, right? But this is lost. That means, is that mean that you have only 3? What happens now? Means you see, if you use Docker Swarm, like let's say this host is down, it will start or create another 2 containers on the available Docker host, making it always 5. That is what is providing high availability for your application. What may happen to the underlying Docker host? your application still have got 5 containers to accommodate the request. That's what is providing high availability for your application, right? Understood. So managing containers means yes, need to provide high availability for them. And also, like I discussed, we'll be deploying containers on a bunch of Dockers. Okay, let's say 2 Dockers. How do you decide how many on host 1, how many on host 2? Do you sit and calculate, then do Docker run 3 times here, 2 times here? That doesn't work, right? We need a tool which have this intelligence to calculate, to schedule the containers by calculating the resources of the host, right? That's what is scheduling the containers on the cluster. Scheduling the containers on bunch of Docker rows, let's say. So auto scheduling, we don't need to tell anything. You don't need to tell, okay, put 3 here, put 2 here, right? So that's what is handled, taken care by auto scheduling the containers on the Docker host, right? And then let's suppose, okay, there are 5 containers today. Tomorrow, like we are going to have huge, the application is going to have huge user base, huge audience, right? We need 100 containers. How do you do the scaling? Increasing the number of containers is scaling up or scaling out. And also, let's suppose, okay, there is a big business of hours, business off timings were like night time. This application is not being used. You can lower them to 10 containers. How do you scale down? Why should you scale down? Why can't you keep them running always? Yeah, anyone, why should you scale down when not required? You can just leave them running.
Unnecessary consuming resources.
Resource consumption, right? So when you don't need these number of containers, let's say 100 containers were distributed across 10 VMs. Okay, in the business of hours, only 10 containers are needed. So maybe just one VM would be enough. All other 9 VMs could be saved, could be stopped, right? Which saves a lot of amount, budget, cost effective. So we should not keep the resources running or leave them idle. So scaling up and scaling down are both important. So how to provide scaling, high availability of your application? How do you provide auto scheduling of the containers on the bunch of Docker hosts? How do you scale them? Right? Not only this, there were many other things. All this comes under managing containers. Simple term, managing containers. Or else a better term could be container orchestration. Right? Container orchestration. So let's talk about container, scheduling the containers, scaling the containers, and then, yeah, not only this, providing rolling updates, rollbacks. What is meant by rolling update? Anyone? What is a rolling update?
It's an upgrade one by one.
Yeah,
One after
suppose, correct. Suppose in this PHP we are running version 1. Okay, I want to start version to upgrade the version. Means like if you talk about from the scratch, means developers made some changes. New index.php or PHP file might have been modified. Means new Docker image has to be deployed, right? So during this upgrade, generally, like in the traditional approaches or without DevOps, we see some downtime, right? End users have to face some downtime. But how do you upgrade the application without end user seeing any downtime, which is called rolling updates? Rollbacks, let's say version 2 is not doing good, there were some issues, we want to go back to the previous version. Rollbacks, that's rollback. So how do you achieve it? So these are some of the container orchestration features. Swarm can do all of them, but these two things means providing zero downtime for the application can be done with Kubernetes more effectively. Meaning this part, these two. Kubernetes can promise providing zero downtime, right? without any downtime. It can help you upgrade that. But Swarm can also do, but how efficiently a tool can do, which tool should we choose? And these are all the features that makes the difference. Kubernetes is the leader here. Like it is, you can rely on Kubernetes for critical applications, which has got low SLA. So Kubernetes should be an option. But smaller applications, okay, even though there can be some downtime allowed for such smaller applications with less budget, for those applications, such applications, you can go for Swarm. But Swarm is very rarely used. Kubernetes is the ultimate leader in this category. No equal competitor with it because of so many other features, advanced concepts. So Kubernetes is super advanced. It has got extensive features, the architecture, everything. It will be totally different. But to understand the basic orchestrator features, let's go through this. These three, high availability, scheduling, scaling, can be done with Kubernetes also efficiently. But to understand the orchestration features, we'll see these three features with Swarm in our course. And the rest of rolling updates, rollbacks, and many others will be implementing with the Kubernetes only. Right. So container orchestrator tools, there were different tools like Docker Swarm, Apache Mesos, and Kubernetes. Right. So let's get started with Swarm. Others are like Swarm, Mesos, these are very less used. But let's start with Swarm to understand the basic features of container orchestration. Kubernetes is initially a product of Google, but now it's managed and maintained by CNCF, Cloud Native Computing Foundation. Anyway, we'll discuss more about Kubernetes when we go to that part. So being discussed, being said that Swarm is a basic or else simple container orchestrator tool. Let's get hands-on with it. Good to go, or any questions in this part?
Does Amazon offer any orchestration tool?
There are managed services, AWS, Google, Azure, all the cloud providers offers. Those are EKS and all. Those are called managed services. It provides EKS, which is nothing but managed service for Kubernetes. We will also learn EKS.
Okay.
Let's begin with the hands-on. But before going to the hands-on, we need to look into a few more things like. So we are going to create a Swarm cluster, right? Right, you will create a bunch of Docker hosts, right, which is nothing but Docker Swarm. So we can create Docker Swarm, which is nothing but bunch of Docker hosts. And in this particular bunch or a cluster of Docker hosts, a group of Docker hosts, right, one Docker host. This is a simple architecture of Swarm. One Docker host would be acting as a manager. Manager means manager is the one which makes all the decisions, like a container should be scheduled on which Docker host, right? All of this planning, scheduling will be done by this manager node. Other Docker hosts will be acting as workers, worker nodes in the Docker Swarm. So you can create a cluster with any number of Docker hosts. Okay, out of which there should be at least one manager Docker host, like one manager node. Others will be the worker nodes. Worker nodes are the ones which should actually run the containers. Managers should be a dedicated node which will take care of, which will do all the management, which will do all the orchestration. Right? But yeah, manager can also run the containers. But the best practice is keep it dedicated. Now we will see how to create a cluster, how to create Docker Swarm cluster, how to create, you have to make one node as a manager and how to make it as a worker. Initially, both of them will run the containers, but how can you keep manager dedicated to run the containers? All of them we shall see, right? And if manager node is down, entire cluster would be down. So you can have the better approach is you should have multi-manager node cluster, right? You can have multiple managers so that even though one manager goes down, another manager will take care of the cluster, right? So let's get started to create a cluster. Here I'm going to create a 3-node cluster. One node I'll be taking as a manager, other one as a worker. But remember, these are Docker hosts. Every machine is a Docker host. It's not a simply VM. Means what you should do? How to create Docker host? How to create a Docker host?
For EC2 instance.
That's all. Just EC2 instance is a Docker host, or how do we have a Docker host created? EC2 instance with Docker, right? Means you have to create an EC2 instance,
Yes.
install Docker there. This, let's say 3 Docker hosts we need to create, means start 3 VMs, install Docker, start Docker. You can automate this part in multiple ways. Here you may use Ansible configuration management tool, or you can use Terraform, or else you can use some scripts, or else there is a Docker native tool called Docker Machine. This is way old. Docker machine, right? Docker machine is tool. Don't get confused. Docker machine means a machine. It's a tool with which you can spin up any number of Docker hosts on any platform. On any platform means Docker machine help you spin up Docker hosts maybe on-prem or else on AWS or Azure, anywhere it can create. Right? It's a separate thing nowadays. We are not using it. Firstly, Swarm is not at all used. Even Swarm is used. We are spinning them with Ansible or Terraform. Docker machine we are not preferring much, but some just some information. Anyway, for now we will create manually because we did not get started with Ansible Terraform. Once we learn that, you can try this example with those tools. For now, I'll just create 3 Docker rows manually. So just start 3 Docker rows. Amazon Linux 2 T2.micro. Use the key pair. AM IST.
Maybe next time we can create our own key pair or we can log in with the same key pair.
You can use the same key pair. See here for our lab, you can use the same key pair. Okay, in reality, every machine will have its own key pair.
Okay.
Oh, sorry, I thought of changing the number. I forgot to do that. Let me create 2 more. We could just change the number here. Here in the summary, 2 more. So Amazon Linux 2. T2.micro. AWS key. Here I would like to do something here. For them to communicate, these Docker hosts should communicate. So allow the traffic so that they can communicate with one another. I'm allowing all traffic. So that they communicate, they should communicate with one another. This is the one for this also. Let me change the secure. Okay, so 3 instances were ready. They were just instances. They are not Docker hosts, right? Let me name one as, I'm just naming it. It's not at manager. We have to make it as a manager. But I just want to, whichever machine we want to make as a manager, naming is as such. This is worker 1 and this is worker 2. They were just VMs. First, we need to make them Docker hosts. So install Docker. Let's connect to the first VM. So this is going to be the manager, but whatever it is, first let's install Docker and start Docker on every machine. Yum install Docker. Meanwhile, let's connect to the other machine. We could also have used user data. What is this user data? We'll see later. We can also automate this when you're creating instance. Let me launch a new session, one more session. This is worker 1, right? This one. Let me rename it. Okay, this is worker 1. And then to the third machine. This is worker 6. Right, so done. Let's install Docker here as well. Okay, so Docker is installed. Let's run Docker on all the VMs. Here also. Okay, so Docker is started on all the VMs. Docker is started here as well on all the three VMs. So these are the three Docker hosts, right? Now they were Docker hosts. Earlier they were just EC2 instances, but now they were Docker hosts. Yes, our Docker hosts are ready. Now we are all set to create a Docker Swarm cluster with them. We need to group them. We need to create a Docker Swarm cluster so that we can manage multiple containers. So whichever machine you want to make as a manager, I want to make this one as a manager, right? Take the private IP of that manager node. See, all these three have to connect, right? This communication or this connection, they should be communicating via, like they will be communicating internally, right? Like there will be some ports open through which they'll communicate. So you can provide IP address, I mean private IP, because communication is within all these AWS instances. Right, so I'm taking the private IP of the machine, whichever you want to make as a manager, and also go to that manager node and you have to start Swarm. You may be having a question, should we install Swarm after installing Docker? Because yesterday after installing Docker, we have installed Docker Compose, right? But Docker Swarm, you don't need to install. By default, you can run your containers in Swarm mode. You don't need to install it separately with the latest versions of Docker. Right? First point. You don't need to install Swarm separately. Docker comes with option to run them in the Swarm mode with all the latest versions of Docker. So no need to install. That's why when I run Docker Swarm, it was not saying command not found. Whereas Compose, right, command not found. Got it. So Swarm will be there by default. You don't need to install it separately. This is another advantage for Docker. See, Docker Swarm. Docker Swarm is a very simple and easy to learn container orchestrator tool, because when you compare with Kubernetes, it has got whole different architecture, everything different, setup will be complex. But Swarm, it's similar, same like a Docker tool, right? So yes, Swarm is already there. Let's initialize Swarm. How do you initialize it? Docker Swarm init advertise IP address of the machine you want to make it as a leader or manager, right? Go to the same machine, whichever you want to act as a manager. Actually, you will be, we need these commands to be executed on manager. All of them don't work on worker nodes, means once you make them worker nodes. So Docker Swarm init advertise the IP address of the machine, whichever you want to act as a manager. You want to run on the same manager node. So when you run this, say Swarm initialize. Current node is now a manager node. To add a worker to this swarm, how to add workers to this swarm? It was giving a token. Do you see here 2377? That's the port through which these nodes will communicate. If you want, you can open only that particular port. But because we don't consider all these configurations in much detail, I have just opened all the traffic. Otherwise, you can open only those specific ports. Fine. Now I want to add another worker node, but before that, because this is Swarm, you can run docker node ls command. This docker node ls will not work on other machines. See, error response. This node is not a Swarm manager. Only on manager you can run. And you see the same master node, I mean the same node manager, you see status as leader, right? Means it become a manager node, right? Clear. Good. Now, yeah, I want to add a worker. So take this token and go to the worker node and apply it. See, this node joined the swarm as a worker. Now, if you again run docker node ls, see, new node added and the manager status is blank, means it's a worker node, right? But still, You can't run any of the commands here. They work only on master manager node. Okay, perfect. So I have got two nodes. One is manager, one is worker. I want to add one more worker node. So let's run this token.
Sorry to interrupt. I didn't get that Docker node in the manager.
Docker node ls will list all the nodes in the cluster. Earlier we created, from the beginning we just created cluster with a manager node. So it is there. Then added a worker node. So that was also, it was listing all the nodes in the cluster including manager and workers. And this command will work only on the manager node. If you go and run this command on worker node, it will not work. It says this node is not a swarm manager. Worker nodes can't be used to view or modify cluster state. Understood?
Yeah, yes.
Now, whichever machine, suppose I want to add one more machine to the cluster. Run this token on the other machine as well. Docker swarm join token. Now, this will be also added. Right? If you just go here and see Docker node ls. See, third one also in the list. Do you see that? The one with this asterisk is the leader, right? And this is a worker one, worker two. Clear? So 3-node swarm cluster is ready. Got it right, everyone?
Yeah, Preeti, one more thing. How will you identify this is worker one, worker two?
This
When
one, manager state. Oh, you mean how do you decide? Here in
Yeah.
our case, we were just taking 3 same machines and we were just choosing like one manager, other 2 as workers. So whichever I choose as a manager, I started Docker Swarm in it. Right? Like that you can choose. But actually, which criteria is actually the best practice is on these nodes, we will be running the containers, not on manager. So manager can be a node with less resources or a smaller node, but worker nodes should be big with the huge resources because that's where we run the containers. That's where we run the workload, right? But in our case, all are same, like same size, and I have chosen one randomly as manager. Whichever you choose as a manager, there you should do Docker Swarm in it and so on. Clear?
Yeah, it is clear.
Right. So, yeah, now I have got one manager with the 2 workers. Let's start some containers, but how do you start the container? Or else where do you start the container? Like as far as we know, as per our learning till now, we will start a container, right? Like Docker run or whatever, you create a container, Docker container. And here in the Swarm cluster, we are having 3 nodes. Manager, worker 1, worker 2. Worker 1, worker 2. Right? So now if I start a container, it may get started anywhere. It may be started here, here or here. Default behavior. It may be started anywhere. Right? It could be started anywhere. And also in a container orchestrator tools like the Swarm, you don't need to bother about where it is running. Like it may be here or here or here, but you should be bothered about whether it is running and providing high availability or not. That should be the concern. Of course, if you want to tie up only onto a particular node, you can do that. But I'm just talking about the general behavior. Also, later on, we should stop this. It should not go to manager because we'll keep manager as a dedicated cluster which will manage. That's all. Don't put workload here for best practices. So it may go to worker 1 and worker 2. It may go here or here. You can't decide. This is what is we learned, right? Scheduling, auto scheduling of containers on the cluster. You don't need to tell Swarm where to do it. But if you want, there might be some specifications. Okay, this node has got 8 CPU, 8 vCPU. I want to run the application here, container here because the container is used. In that case, you may choose that. But generally, this is how it may be. It can do auto scheduling. It can take a decision because if your container is huge, it can decide it should put it on a huge. It has got that intelligence. But still, there might be some specifications. Okay, let's suppose this is Ubuntu instance, or else on this machine you have got some packages installed. Some kind of specifications might be there. This might be a memory intensive node. Let's say we have T2 family, right? T2.micro we have chosen. There were M5 family nodes and so on. Let's say my container, which one container is memory intensive application, means it uses more memory. I want to run only on worker node. You can do that, but auto scheduling can be done by this Docker Swarm. Right? This is what is auto scheduling. Yeah, so now, yeah, your container, but in our case, we did not restrict manager also. So it may be going on any node. And remember, it could be running anywhere. You should not bother about it unless, like I said, you have memory specific applications. You want it to go to a particular. Otherwise, it can be running anywhere. Still, your application can be accessible. It is highly available. This is what your concern should be. You need not bother about where it is running. Okay, this is first thing. And then let's suppose I started a container. It means the application is running on port 80. I have forwarded this to host port as 8001. So now you may be having a question. Host port means, is it this on this manager, or is it on this worker, or here, isn't it? Let's suppose your container is running here. Your container is here. So do you mean that you hit worker 2 and then access, hit on 8001, then only you access? See, it can be accessible even though the container is on worker 2, you still can hit this worker 1 or manager on 8001 to see the application. That's why this is called cluster-wide port. It's no more called host port on Swap. It's called cluster-wide port. All this information is important. I would suggest you to have a running notes, mention all the pointers. At least you can't write the whole sentence, the words cluster-wide port, so that it would help you for a quick glance during the interview kind of, right? Okay, so this is called cluster-wide port, meaning you hit any node on this port, even though container is not running, because you are not, you should be least bothered where your container is running unless you have specific requirements. So it could be running anywhere. It may be on worker 2 or worker. Still, you hit any node on this port, application can be accessible. It's called cluster-wide port because they were connected. This particular port will be open across all the nodes because they were connected in a cluster. This particular port will be open across all the nodes, so application can be accessible on all the nodes. These are the few things you have to remember. There is also networking in Docker Swarm. I don't think you need to go to that extent, but yeah, first let's get on hands-on with this. Let's start a container. Now, how do you start a container on this Swarm? Do you still use Docker run? We don't do Docker run, but we will create the container in the form of service using Docker service create command. What is service? For some time, you can consider service is like an entity or a bag or a holder, which will hold all your application replicas or else all your container replicas. Means let's say, okay, I want to run PHP container, 3 containers. All those replicas like PHP1, PHP2, all of them will be handled with the single service. So just understand for some time, service is means you create a container as a service. Okay, you will get more clarity on service once we do scaling. First, I'll start one container. Let me create a container. So on the manager only you have to do these commands. Okay, now Docker service create name of the service, let's say web service, and the image name. I would like to use this image. I would like to use this PHP 8. Let me try. I think I should do Docker login all over, right? Just let me pull this and see. PHP 8 DevOps trainer. Now I don't want to do Docker login on all of them. Let me see if I have something here. Deploy. I think we have it here. Anyone stored them on public? Yesterday's images? Let me try. PHP 8. So web is the service name. Okay, with port forwarding, I want to forward onto port 8001 and the which port? 80 port, and the image name is right. Could not be accessed on a registry, right? Do you see that? Possibly leading to different nodes running different versions of the image. It was saying some message, no such image. Firstly, it doesn't have access to pull it. Java, mem, and private repos, PHP 8 is the tag. Let me try doing Docker login. We should do here also. It should run, right? But let me check. Then I'll do that. Port 8001. Okay, already it might have tried to start there. So just let me put it on 8000. Already exists. So service is created actually. Let me show you. See Docker service ls. See, it could not start. Here you see 0 by 1 replicas. It could not start successfully, but service is started. Let me remove it, or you can put another name. Docker service RM service name is web. Okay, gone. Now let me try on 8002. Still it's saying could not be accessed on a registry to record its digest. Maybe prefixing it with registry as well, but default registry will be Docker Hub only. Docker service RM web. Let me do Docker login here. try now. Till Java Maven private repos image could not be accessed on a registry to record. Each node will access independently, possibly leading to different nodes running different versions. No such image. What's wrong in the image name? PHP 8 is the tag. That was the same I was using. No such image. Sorry, I'm speaking on mute. Can you hear me now?
Yes, please.
So first
Yeah,
pull the image, then apply it in the service command, right? Directly when you are doing it in service, it's not doing. Pull the image, then do it. So fine, yeah, service is created and also replicas, they were successful, right? But let's suppose I want to know where this service is running. Isn't it? Where the service in the sense, service name is where, which is having one replica of PHP. So I want to know where it is running. How do you do that? Docker service PS web. Right, if you see that, yeah, it was showing it was running on the same node, which is manager node, right? It was running on the same node, which is okay, but there is some error regarding the port, I believe. This is an error regarding the port. Let's do one thing. I'm just deleting this Docker service RM web. Will create it on a new port. Maybe this port was not empty. Let me just check with port 8000. Docker service ls, Docker service ps. PS will show you information. Still error is shown. We'll look into that error later. So yeah, it was running on the manager node, right? By default, like it was going on to manager node. Maybe it was having enough resource or whatever it is. It was running on manager. Fine. Like what if you want to scale your service? Also, before that, let's say accessing it. It's running on the manager node, right? But as we discussed, even though it's running on manager node, it should be accessible on any other node, right? First, let me check on manager itself on port 8000. Yeah, you have got it. Then let's check it on. This is no wonder it's running on manager only. Let's check on the some other worker node. We don't have anything on worker one, right? But still, let's check this out. Yes. Do you see that? Every node, this particular port application will be accessible on the particular port because they were joined with a Swarm cluster, and this particular port will be open across all the nodes. Right? They'll be communicating, and this port will be open across all the nodes. So yes, it is available on all the nodes. This is one thing clear. So it is running on manager node, but still we can accept the application from any node. Then let us try to scale this. Suppose Docker service ps web, right? I have got one. See here web.1. Like I told you, it will be like an entity. Our service is like an entity. This entity name is a web. Within this, I started one replica. Now php.2 or web.2 actually, right? Service name.2. Like this, you can scale up easily. Right, that's a service. It's like holding the particular set of replicas. Now I want to scale the application. First, let's say scaling, right? The one of the container orchestration feature. Okay, let's do the scaling. Docker service. Suppose I want to scale out. I want to increase them. Docker service scale web equal to 5. I'm starting 5 replicas of PHP. You have to pull them on other nodes also. Let us say. We should do that because like it will be starting containers here. As of now, you don't have any containers here. Already 5 of them are running. Let's say I believe they might have started on manager. Docker service ps web. It will show you where they were started. If you see, do you see that they were all on this node only? Actually, they started on other nodes also, but rejected because there is no image, right? See, can you see that? They tried starting on other nodes, but could not. Only the success ones were all on the manager node only. And also, see, you can also make it clear. Docker PS, 5 containers, but on worker node, Docker PS, right? Nothing here. Even here also, there is nothing. So what you can do, let's pull the image here as well. Docker pull. These are the Docker host. So make sure you are having your image here. This is worker 2. Docker pull. Right. So you have got the image available. So now what? Let's scale up further, or else what we can do is we shall delete this and you can restart it, or else scale it up. Let me scale up. Docker service to 7. Right. Let's see if they have started here. With the Docker PS, we can check here on the worker nodes. Generally, we don't step into worker node. We can check from master itself, but just to show you, see, one container started here, the another one also, Docker PS. Do you see that here? So we started 2 new replicas. They got started here. Understood, everyone? So total, how many replicas were there? Docker service PS web, right? It was showing you all the 7 replicas, right? 4, 5, 6, 7 running. Docker service ls. So see 7 by 7, like 7 replicas, all the 7 were ready. And where are they running? They were shared across all the nodes. If you want to see clearly, see Docker PS on master 5, on worker node 1, on worker node 2. Sorry, on worker node 2, worker 2 also 1. So total 7 were there. But like I said, we should always keep manager a dedicated node, right? We should not put so much load on manager. It should be a dedicated node which will handle only the load. This is scaling. Let me also show you one more thing. What if you want to scale down? Just the number, that's all. Let's say I want to scale to finally to 5, right? Let's see. This is scaling down, just the number, that's all. Let us see the containers now. I think the command is not good. Okay, fine. Docker PS on manager, only 3. On the worker 1, this is worker 1, 1. This is worker 2. On worker 2 also 1 container. So 1 here, total 2, here 3, total 5. Right? That's how you can scale out or scale it. But like I said, this is not a good practice. Don't put workload on the manager. Leave it for managing the cluster. So how can you do that? Yes, that is possible. You can drain the manager. See, availability active means they're all ready to take the load. But I want to put availability off. Means manager will be still running. If manager goes down, entire cluster will go down. But what I want is manager should not take up any load. Right? So for that, you can update the node availability. Docker node update availability drain this particular DNS, right? That's all. So Docker node update availability drain means this availability flag will be in drain state, means it will be up and running, but still it will not take any containers. Then what happens to the containers here? Let's see. Now you see the node ls. See, manager availability is in drain now. Now if you see Docker PS here, see no containers. Does it mean that these 3 are lost? What happens to them? They will be started on other available nodes. See, one additional one started here. 2 were there. See, other 2 started here. Total 3 here and 2 here. Total 5. That is what is again high availability. Your node may be gone or crash. Something may happen. Of course, here I have drained intentionally. Doesn't mean it's gone. Okay, it's still running. See here. Your manager is still running. That's why you are able to run the commands. You can connect to it and manage your cluster. Otherwise, cluster will completely go down. This is my manager. It's still working, but it will not take any load. See? Got it, everyone? Understood?
Yeah, it's breathing.
Right? So, let's suppose I want to scale. See, all the scaling, everything you should do, still do from manager only. Let's suppose I want to scale them. Let's say I want to scale them to 7 again. All the 7 will be on worker 1, worker 2 only. You can't put that on manager because we have drained the manager. Manager is in drain. So if you do Docker PS, you don't see anything here. And here, if you check Docker PS, see 4, another 2 started here. Did we tell anything where it should start, how it should start? See 3 here. Total 7. Always this is what is high availability. So I have drained here intentionally. I have put this off. What if by mistake some node crash? Then also same thing. Let's suppose this worker one got deleted. You may delete it from the swarm, or else you may do like stop it or whatever you want. Right? So now you could drain this as well. Like let's say I'm draining this as well with a Docker node update availability. Update availability 7.70. What happens then? Let's see. This is 7.70. Correct? Means which one is this? This one. Worker one where 4 containers are running. I'm draining it. Means you can shut down, you can remove it from swarm. There is a command Docker swarm, remove that particular node. It will be removed from the swarm. So just I'm draining it. Okay, now if you see node ls, yeah, it was also drained. Now these containers might be gone. The container will be gone. It's not that this container, same container 1110 is moved. It will not move. Okay, it will be shut down. New container will be started. See, there is nothing like 111 if you see. New container will be started. But see, all the 7 here in whichever node available. Also, now if you see Docker service PS web, you will see they're moving also. See these arrow marks? Right, whichever is on some other node. See here, this is earlier one, yeah, 70. Right, you could see they were moved to other node. You can see this with arrow. They were moved in the sense actual container is not moved. New container is started with the same image because it was in the same service. So a new replica will be started in the other available node. Clear, right, everyone now? Suppose I want to bring this active. Docker service ls. I want to bring this node back. Let's say I want to bring it active. Yeah, you can do it. Let's say, see, when do you drain it? Generally, like I told you, manager, you can drain it so that to put it off from load. Later on, right? Like later on, you might have, you might want to put some maintenance state. You want to put it off for some time. It will be running, but if you just want to put it off also, you can drain it. Later on, if you want to bring it active again, active, so that it will be ready to take the load from next time on, whenever you scale or see it is active. So scaling, high availability, auto scheduling of the containers. Were these 3 features clear for all of you? The basic features of orchestration. The same concepts in Kubernetes also, but the architecture, how it works, those will be different. Is this much clear, everyone?
Yes.
Sharon, I'll take up your question in a while, right? I'm going to start DB also. Then I'll answer your question regarding volumes. Okay. So let's do one thing. So I have got one service, like Docker service, ls web. Let's start DB service also, right? Let's first pull the image. Do I have this? Okay. So actually on manager, we don't need now because we are not running anything on manager. But let it be Docker service ls. We are having 7 replicas. I would like to scale it down because we are going to start DB. If enough resources are not there, it might be a problem. And also, how do you check the resources? There is one more command called docker stat. Docker stats, I think. Docker stat will show you the memory consumption of the containers on that particular node. This is manager. On manager, we don't have containers, so it was not showing anything. Let's see here. In the standalone mode also, you can check. Like earlier how we did Docker, and at that time also, you can check this way. It was not showing anything. Maybe in the swarm mode, it is not working. Or else, one second, Docker PS. Docker stats should show all the container consumption, all the resources. Docker stats of this container. Okay, put the container name, then it's showing. Actually, otherwise, if you are just running in the normal mode without swarm, it will list all of them. But mention it. So, do you see how much memory it was using and what is the limit it has, memory percentage, right? Network input, output, everything it was showing. Okay, so just to make sure to be of the resources, I'm just scaling this service down. Docker service scale web equal to 2. And let it be 2 replicas. Okay, 2 replicas. Where were they? I believe one should be here. No, both are on the worker node only. Yeah, see, because already they were there, right? It just shut down. So yeah, 2 are here, which is fine. Now let's start another service. See, you like this, you can have multiple services, right? This is front end. What if you want to start a backend as well? Yeah. So let's create one more service for backend. Docker service create. Name is DB and the image. This is the image. I don't want to do any port forwarding. So no -p. That's all. Service name is DB and I'm starting this. Detect a task failure. Detected task failure. Let's see why it failed. Docker service create name. Let it finish. Oh, see, on the manager we have pulled. Have we pulled that here? Oh, okay. I think we did. Okay, so it should work. Let's wait. So you can have multiple services this way and they would be communicating automatically. Again, you don't need to do anything for them to communicate. Docker service to check the progress. Docker service ls. DB could not be started. Docker service ps DB. What happened? It was saying one preparing less than a second. Just is it started? Here anyway it will not start. Let me try once again. Docker service ps. Docker service rm db. Let me create again. So meanwhile, what happens here is it will start one more service, right? We are having web service like that. It should start one more service called DB. And if you are doing this way, let's suppose two services I'm doing this way, right? Like Docker service, one after the other. What if you have multiple services? Again, creating services like this also would be painful when you have huge number of microservices, right? What you can do is you can also run your Docker compose here directly. Docker compose file is there, right? You can run this compose file with the swarm mode. That is the actual point. Here, if you start multiple services, you have to start one by one. You have to take care of them. Multiple services can be managed through compose. Means you will run this compose file in the swarm cluster. That's the actual part. This way, running individually will not work. You can run it directly. And if you see that particular one, yesterday, the compose file which we created, this one, right? So you can run this compose file directly in the swarm mode. Of course, you put the image name here. Rather, if you want to put it in the run it from the pipeline, again, you have to add one more stage through swarm. Otherwise, put the command here and it should be running the same way. Now what happens? Like, let's say I'm configuring volumes, right? Here, whenever you are running in the swarm mode, volume, where should be volume there? Volume is nothing but a Docker directory which will be on the same machine. Means volume should be created on this machine as well as on this machine. Means on whichever machine container is started, volume will be created on that particular machine to have a backup. And again, how it will have backup when you are about the stateful applications like SQL and all. Here in Swarm, we don't have effective management of that. Lot of manual work have to be done. Whereas in Kubernetes, to manage such stateful applications means each database replica would be different. In that cases, managing volumes would be different and efficient. That part of stateful applications, persistent volumes, volume claims, those we'll talk about in Kubernetes as well. Hope that answers your question. See, it was taking too long, but what I'll do is I can just start the container here through the compose. I'll just start running it here. Docker service rm db. Let me try to run this. I'll show you how to run this. What is the image name? Java Maven private repos PHP 8, right? And I don't think this is needed here. Few changes we need to make. This is fine. right? So how do you run this? You can run this compose file in the Swarm. Let me remove other services available, like whatever we have. Already this web service is there. I'm deleting this Docker service RM web. This is how you can delete the service. All the replicas will be gone, right? No web containers, no PHP containers. Okay. Now we can run this compose in the Swarm mode. This is the advanced part. What you can do is Docker stack deploy is the command, and you will pass the compose file with a compose flag. Compose file, it was in the same path, and give some name to your stack like PHP DB stack. PHP DB stack. That's a stack name. See, it will create network services, right? It has created all your services, everything will be prefixed this way. So now if you see Docker service ls, right? See, DB started one replica. This one started two replicas because we have given replica number. And where were they running? Docker service PS web. Which one you want to see? Web. Oh, its name is PHP, I think. What is the name? Okay, see, your names were prefixed with this, your stack name, right? I have given stack name as PHP DB stack. So your services are prefixed as such. So, right, they are running on one is running on 189, one is on 170, meaning if you come here, Docker PS, okay, SQL is also here and one PHP. And here, right, here also one PHP. So they were all good, running on worker nodes, nothing on the manager, right? Let me check on the port 8001. Port 8001. Okay, it was there. Let me try to save some data. Right? That's all. You need not do anything now. It was stored at the backend. Right? Like before, you can run the compose file in the Swarm mode. Means in compose yesterday, if you are running container directly, we are running on one single host, right? But now on multiple hosts. This is what is Swarm doing. Swarm integration with compose. Both of them working together here. Also, if you want to check Docker volume ls, it was not showing here. Docker volume ls because it should create. See, it has created only on worker node. Why not on manager? Anyone? Yes. See, here also there is no volume. Why? Why only here? Because see, like I said, whichever machine it is running, there you need to have the volume, right? It has created volume on that particular machine. Suppose you scale up your containers, right? Let's say you scale up this one. Yeah, you scale up your SQL containers as well. Then another volume will be created here for that container. Again, managing those volumes for consistency, that's going to be a different story. This kind of complex applications like managing with the volumes and all, better we go for Kubernetes. It can manage them efficiently. But yeah, here is. Got it right, everyone? Any more questions? And this is the compose file for Swarm. Just a small change. You don't need to allocate port separately. Sorry, this is work. You are breaking. Hello, you are breaking completely. Can you please come again?
In the first node, if you scale up, it will be recreated another node, right? So how come that time what will happen that volume?
Hmm.
I'm audible now?
You are audible but breaking completely. No clarity in your question. Anyone understood the question? He was saying something like when you scale up, what happens to the volumes? Is that your question?
Yes, yes, sir.
Okay. When you scale up the SQL, right?
Yes.
Isn't it? When you, because volume is attached to it. That's what I'm saying. When you scale up, see here only one, on whichever machine the container is being created, on that Docker host, volume will be created. Now it was got created on worker one, so volume is created. If you scale up, let's say 2, another container will be created here, volume will be there. Now volume is not there. Let's suppose you are creating multiple hosts, let's say 4. Right? 2 containers, 2 SQL might be here. Yes, they'll be using the same volume, this same volume. There you will get a complexity of data consistency. Correct? What would be the problem then? See, let's suppose here SQL replica 1 is there, replica 2 is there. Both if they access the same volume, because it's a stateful application, there would be a challenge. Right? In Swarm, you don't have a inbuilt or a native objects of Swarm to handle such complex applications. That's where Kubernetes should be a preferred option. Okay, we'll talk about the stateful sets, handling the volumes for such stateful applications in Kubernetes. Hope that answered your question.
Yes, sir.
If you scale up, no problem. You scale up 3, all of them will use same volume. What is the problem? Everything can use same volume, all the replicas. But problem will come if it is a stateful application regarding data consistency. What is that problem and how to handle it? We'll look into them in Kubernetes because like I said, Swarm is not efficient to handle such tasks. And this is the file for Swarm. If you want to run the same in Swarm, this is the file you should use. I'll also place in the same repository. Same repository saying that compose file for Swarm so that it would be easy for you to identify. Just a port number, you have to put only one port. You don't need to assign multiple. And here, Docker compose for Swarm so that you can identify better. It is actually. Okay. So that is all about Swarm. We have seen the basic container orchestration features here, right? Like high availability. What is meant by high availability? What is meant by scheduling the containers, like auto schedule of containers across the multiple nodes in the cluster, and then scaling out and scaling in, right? How about rolling updates, rollbacks, and many more. Okay, we'll get started with them in Kubernetes. I'm sharing a quiz now on Swarm. You can take it up. And also any further questions you have, you can put your queries now. We are slowly approaching to the production environment deployments. Compose can be used for testing dev, but not for prod. Swarm can be used for prod, but to a little extent only, like for smaller applications, right? So the realistic enterprise application, how to deploy them and all, we'll see. Got the URL? I have shared it in the Zoom chat. Hope you all got the link. And once this hands-on is done, terminate all the instances, right? Like manager, worker 1, worker 2. We have started 3 instances. Make sure to terminate them or stop them. You can get started with the quiz.